Hello everyone. We have a question which says that a small smooth ring R, which is over here, of mass 0.2 kg, the mass of the ring is 0.2 kg, multiply it by 10 so that we could get the weight of the ring, because weight is equals to mg, is threaded onto a light inextensible string ARB. Because it is a ring, so the string is ARB and this string is passing in between the ring, so definitely this is basically a single string, not two different strings. So the tension in this string would be same as I have mentioned over here, the tension over here as T and the tension over here also as T, because it is a single string. The two ends of the strings are attached to point A and B, and definitely we can see that this string and the two ends of the strings are attached at point A and B on a sloping roof, and this is the sloping roof inclined at 45 degree to the horizontal, and this sloping roof is inclined at 45 degree to the horizontal. A horizontal force of magnitude P Newton acting in the plane, this is a horizontal force of P Newton, it is acting in the plane ARB, so definitely this ARB is basically passing through the ring and this force is being applied on the ring, so definitely they have an interrelation with each other. The section BR is over here, the section BR of the string is perpendicular to the roof. The section BR of the string is perpendicular to the roof. This is the roof and this section BR is perpendicular, that means it is making an angle of 90 degree, this section with the roof. And section AR of the string is inclined at 70 degree and this section AR of the string is inclined at 70 degree to the horizontal, and this AR and this is a horizontal, so it is making an angle of 70 degree to the horizontal. The diagram and the statements are very clear. According to the statement that the system is in equilibrium, that means we have an equilibrium condition. Find the tension in the string and the value of P. Basically we have to find two things: the tension in the string, which is T, and the value of P, this force P Newton, which is being applied on the ring. They have just given us one condition, that is equilibrium. An equilibrium condition means opposite forces are equal, and when we say opposite forces are equal, that means the opposite horizontal forces are equal and the opposite vertical forces are equal. So for that we have to split the forces into components, the horizontal component as well as the vertical component. For that, first of all, we have to understand what the horizontal and vertical components are, because I have seen that most of the students have a misconception that the horizontal is always a cos component. No, it is not like that. If the angle theta is with the x-axis, then the side next to that would be a cos component of that particular force, and the opposite side would be a sine component of that particular force. But if the angle theta is with the vertical, that means the y-axis, then the side next to that would be a cos component of that force and the opposite would be a sine component of that force. So basically it depends upon the angle, whether the angle is with the x-axis or with the y-axis, and based on that we could easily get the components, the cos component as well as the y component. So splitting up the diagram into horizontal and vertical component, if we just look at this 70° and we have the tension in this string, so the horizontal component of this t with 70° over here with the horizontal, this would be t cos 70 and the vertical would be t sin 70. And similarly, if this is 70°, and as mentioned in the diagram over here, the section BR of the string is perpendicular to the roof, that means 90°. And if that is 90, this is also 90. And because this line, this is a horizontal force, so definitely if we just extend this line, so definitely this is horizontal, this is also horizontal. And because the two lines are horizontal representing a parallel condition, so this is 45°, this is also 45°. And when this is 45° and this is 90°, adding 90 and 45, which is 135, subtracting from 180, again we would end up with 45° over here. So finally we can say that we have this part over here, again the tension in this part of the string making an angle of 45°. So the horizontal component would be t cos 45 and the vertical would be t sin 45. And finally we have splitted up the given horizontal and vertical component. Now just work out the values for that based on horizontal forces and vertical forces. If we just consider the horizontal forces, just look at the horizontal forces. We have a P Newton as a horizontal force as well as T cos 70 a horizontal force. Both are pointing to the left, and a T cos 45° a horizontal force pointing to the right, because the condition is an equilibrium condition. That means opposite forces are equal. So the sum of this P and T cos 70, P plus T cos 70 would be equal to T cos 45. And P would be equal to T cos 45 minus T cos 70. Cos 45 is 0.707 with T, cos 70 is 0.342 with T, and because both are in terms of T, we could subtract these numbers and we can say that 0.365 T is equals to P, and this is our equation 1. And the equation is of the form of P in terms of T, and definitely we have to find both of them, because in the question they asked us find the tension in the string and the value of P. We have to find tension as well as the value of P. So this is an equation based on horizontal. We will make another equation based on vertical. If we just look at the vertical forces and look at the diagram, we can easily see that we have a vertical force T sin 70 pointing upward. This one T sin 45 again pointing upward, and then the mass of the ring 2 Newton pointing downward, because the condition is an equilibrium. That means the sum of these two, T sin 70 plus T sin 45, would be equal to this 2, and after that we could simplify it. T sin 70 is 0.9379 with T sin 45 is 0.707 with T equal to 2, adding both the T equal to 2, dividing and finally getting the value of T as 1.21 Newton, and placing this value of T over here in the equation 1 and multiplying it by 0.365 as we have done over here, we could find the value of P. And this was the requirement of the question, that is to get the value of P as well as the tension in the string.